A powerful magnitude 6.1 earthquake struck 56 kilometers east of Modi's, Indonesia, early on February 26, followed by a series of aftershocks that rattled the region throughout the day. The tremors were not isolated. Just hours later, Japan experienced a magnitude 5.8 quake deep beneath its southeastern coastline, while California's infamous San Andreas fault saw a 3.9 magnitude tremor. These events, though geographically distant, serve as sobering reminders of the immense forces at play beneath the Earth's crust. Each of these locations lies near major fault lines responsible for some of the most devastating earthquakes in history. While no significant damage or casualties have been reported this time, the underlying mechanisms driving these quakes are building toward future potentially catastrophic events. Indonesia, located at the convergence of multiple tectonic plates, is one of the most seismically active regions in the world. The 6.1 magnitude earthquake near Modi originated at a shallow depth of 10 kilometers, making its shaking more pronounced at the surface. In the hours following, a series of aftershocks struck the same region, the strongest being a magnitude 5.0 just 3 hours later. Other significant aftershocks included a magnitude 4.9 at 11.6 kilometers depth, another 4.9 at 21.9 kilometers depth, a 4.8 at 9.7 kilometers depth, and several others ranging between 4.5 and 5.1 magnitude. These successive tremors indicate continued stress release along a fault system that remains dangerously active. Prior to these quakes, on February 25, a magnitude 4.9 earthquake had already been recorded 58 kilometers north-northeast of Batang, Indonesia, at a depth of 128 kilometers. This earlier event may have been an early indicator of stress redistribution leading up to the 6.1 quake. The region is influenced by the complex interactions of the Eurasian, Indo-Australian, and Pacific plates. The primary culprit for Indonesia's frequent earthquakes is the Sunda megathrust, a massive fault where the Indo-Australian plate is subducting beneath the Eurasian plate. This subduction zone was responsible for the catastrophic 2004 Sumatra Andaman earthquake, M9.1, one of the deadliest natural disasters in human history, triggering a tsunami that killed over 230,000 people. In northern Sulawesi, where this latest earthquake occurred, the North Sulawesi Trench and the Gorontalo Fault System are key players in the region's seismic activity. The North Sulawesi Trench marks a subduction zone where the Philippine Sea Plate is forced under the Eurasian Plate, capable of producing large megathrust earthquakes. The Gorontalo Fault, running inland through Sulawesi, accommodates lateral movements and is responsible for many shallow destructive earthquakes in the region. In Japan, the magnitude 5.8 earthquake struck southeast of Shingu at an extraordinary depth of 394.455 kilometers. Deep focus earthquakes like this are associated with the Pacific Plate subducting beneath the Philippine Sea Plate in the Nankai Trough, a dangerous subduction zone that has produced some of Japan's most devastating earthquakes. While the depth of this particular event meant less intense shaking at the surface, it is a stark reminder of the tectonic pressures accumulating beneath the region. The Nankai Trough is a known source of megathrust earthquakes, and historical records indicate that massive quakes, sometimes exceeding magnitude 8, occur here roughly every 100 to 150 years. The most recent major rupture in this region was the 1946 Nankai earthquake, M8.1, which triggered a deadly tsunami. Scientists warn that another Nankai Trough earthquake is inevitable, with the potential to cause widespread destruction along Japan's densely populated Pacific coastline. Meanwhile, California's magnitude 3.9 earthquake near Tres Pinos occurred along the San Andreas Fault, a major transform boundary between the Pacific and North American plates. This fault is one of the most studied in the world and is responsible for some of California's most devastating earthquakes. While a 3.9 quake is relatively minor, it is a reminder that the fault remains active and stress continues to build. The last major rupture along the northern San Andreas Fault occurred in 1906 when a magnitude 7.9 earthquake leveled much of San Francisco and killed over 3,000 people. The southern section, however, has not seen a major quake in over 300 years, leading seismologists to warn that a catastrophic event, potentially exceeding magnitude 8, is overdue. Now, let's check the latest earthquake updates from around the world. In the last 24 hours, seismic activity has been recorded across multiple regions, with deep tremors striking the Pacific, South America, and the icy expanse of Russia's Chukotka region. While no immediate threats have been issued, these events are critical in understanding the dynamic forces that shape our planet and have, in the past, led to catastrophic consequences. The South Pacific saw significant deep-focus earthquakes, including a magnitude 5.3 south of the Fiji Islands at an astonishing depth of 572.247 kilometers. These quakes originated within the Tonga-Fiji subduction zone, one of the most seismically active regions in the world, where the Pacific Plate is sinking beneath the Indo-Australian Plate at an alarming rate. The extreme depths of these tremors suggest that the subducting slab is deforming and undergoing phase transitions, physical changes in the minerals deep within the Earth's mantle that can trigger seismic waves. While such deep events rarely pose tsunami threats, they indicate ongoing strain within the plate, potentially leading to shallower, more destructive earthquakes in the future. The Tonga-Fiji subduction zone is one of the fastest-moving subduction systems on the planet, with the Pacific Plate plunging beneath the Indo-Australian Plate at rates exceeding 24 centimeters per year. This relentless movement fuels both deep and shallow seismicity, as well as the formation of volcanic arcs that mark the tectonic scars of the region. This is the same tectonic setting responsible for the 2009 Samoa earthquake and tsunami, M8.1, which was triggered by an outer rise event and sent devastating waves across the region, claiming nearly 200 lives. The recurrence of deep quakes today serves as a reminder of the strain accumulating in the subduction interface, where megathrust events have the potential to generate future tsunamis. A stark contrast to these deep events was a magnitude 4.8 earthquake south of Oahu, Tonga, at just 10 kilometers depth. This shallow rupture could be a sign of stress accumulating near the Tonga Trench, one of the most dangerous seismic zones in the world. Shallow earthquakes in subduction zones often carry a higher potential for destruction, as seen in the Tonga earthquake of 2022, M6.2, which sent shockwaves through the region, causing landslides and structural damage. Meanwhile, South America also saw deep movement, with multiple earthquakes striking the Andean region, including Bolivia, M4.1, 28.9 kilometers deep, Chile, M4.3, 134.5 kilometers deep, and Argentina, M4.3, 134.5 kilometers deep. The Peru-Chile Trench, where this subduction occurs, is a well-known seismic hotspot that has produced megathrust earthquakes capable of immense destruction. The most powerful earthquake ever recorded, the 1960 Valdivia earthquake, M9.5, originated from this very subduction system, unleashing a tsunami that reached as far as Japan. The Bolivian and Argentine deep-focus earthquakes are particularly interesting because they occur within the South American Warari-Benioff zone, where the subducting slab remains intact deep into the mantle. The region has previously witnessed one of the deepest and most powerful earthquakes ever recorded, the 1994 Bolivia earthquake, M8.2, at 631 kilometers depth. While deep-focus earthquakes rarely cause surface damage, they provide crucial insight into the fate of tectonic plates as they descend into the Earth's interior. Further north in Alaska, seismic unrest continues. A magnitude 4.2 earthquake struck south of Sandpoint, Alaska, at a shallow depth of 2.3 kilometers, indicating stress release near the Uan subduction zone, a known generator of large tsunami-genic earthquakes. This area was the site of the 1964 Great Alaska Earthquake, M9.2, the second most powerful earthquake in recorded history, which triggered a tsunami that devastated coastal communities. The shallow nature of this latest quake suggests ongoing stress along the Alaska-Uan megathrust, one of the most dangerous fault systems in North America. In addition, a magnitude 3.2 earthquake struck 101 kilometers south-southeast of Unalaska, Alaska, at 35.0 kilometers depth, occurring along the subduction interface of the Pacific and North American plates. The region remains at risk for future large earthquakes, as seen in the 2012 Alaska Peninsula earthquake, M8.2, which sent tsunami warnings across the Pacific. In Europe, seismic activity has surged dramatically in Greece, where an astounding 776 earthquakes were recorded in the past 24 hours. The most significant event was a magnitude 4.0 earthquake in the Dodecanese Islands, Greece, occurring at 5 kilometers depth on February 26, 2025, at 12:04 Universal Time Coordinated. This quake was located 158 kilometers from Heraklion and reflects the immense seismic strain in the Hellenic Arc, one of the most complex and seismically active subduction zones in the Mediterranean. The The seismic activity around Greece and Santorini continues to evolve, with the daily number of earthquakes showing a gradual decline. However, stronger tremors are still occurring in the region, particularly in areas where previous earthquake swarms have been concentrated. This pattern indicates that the situation remains dynamic and uncertain. While no magnitude 5 earthquakes have been recorded in recent days, 2 notable tremors measuring 4.3 and 4.1 struck within the past 24 hours, accompanied by approximately 20 smaller quakes. At this stage, it is impossible to determine whether the swarm is subsiding or if seismic activity will escalate again. The situation remains unpredictable, requiring close monitoring. Although the temporary reduction in earthquake frequency provides some relief to residents, this apparent calm could be misleading. Subsurface pressures may still be accumulating, potentially leading to a resurgence of seismic activity or even volcanic unrest. If another magma intrusion occurs, similar to previous intrusions detected beneath Santorini, it could reactivate fault lines in the region. Tectonic forces at play further complicate the scenario. Historical precedents such as the 1959 sequence of a magnitude 7.7 earthquake followed by a 6.9 demonstrate the potential for larger seismic events. Additionally, the possibility of volcanic activity remains, with the undersea Colombo volcano presenting a latent threat. Significant geological changes could be unfolding beneath the surface, including increased pressure, weakened rock layers, and the formation of new fractures. Even a single moderate earthquake, such as the recent 4.3 magnitude tremor, could act as a trigger for further seismic or volcanic activity. Recent data indicates ongoing unrest. On February 26, a 2.6 magnitude quake was detected slightly west of Santorini. Meanwhile, activity on February 25 appeared more pronounced than the day before. Notably, a small earthquake of magnitude 1.2 struck at a depth of 15 kilometers near the Santorini caldera, while another tremor, a magnitude 2.2 at a depth of 6 kilometers, was recorded near Kenny Island, the site of Santorini's magma chamber, and observed ground uplift. These ongoing microseismic events raise critical questions about whether the system is recharging and if new magma intrusions could soon reinitiate activity in the region. The situation in Santorini remains complex and concerning, not only due to ongoing seismic activity, but also because of the structural risks posed by widespread, unregulated construction. While the recent reduction in earthquake frequency might suggest a temporary lull, there is no certainty that the crisis is over. With the upcoming tourist season approaching, another urgent issue demands attention: the stability of the island's iconic cliffside buildings. Many of these structures, including hotels, homes, and bed and breakfasts, are precariously built into the island's volcanic cliffs. Experts warned that nearly all of them were constructed without permits, proper foundations, or geological assessments. Santorini's cliffs are composed of layers of volcanic material, which are inherently unstable. The constant seismic activity over the past weeks may have further weakened these fragile formations, raising serious safety concerns. Seismologist Andreas Solentis, a respected expert and former director of the Athens Geodynamic Institute, recently resigned from a National Earthquake Committee. He cited political interference in the scientific monitoring of Santorini's seismic crisis, suggesting that authorities might be downplaying risks to avoid disrupting tourism and economic interests. Solentis has publicly expressed deep concerns about the extent of unauthorized construction, stating that it is nearly 100% illegal and poses a severe risk to residents and visitors alike. According to him, even government officials from the Ministry of Environment and Energy acknowledge the problem. The potential dangers extend beyond earthquakes. Heavy rainfall or additional geological stress could trigger catastrophic landslides, sending entire cliffside structures tumbling into the sea. Given that some of these accommodations charge as much as $1,620 per night, the stakes are high, not just for the local economy, but for the lives of those staying in these buildings. Some safety measures, such as advising pool drainage to prevent earthquake-induced structural failures, highlight the level of risk involved. While Santorini's dramatic cliffs and breathtaking views continue to attract millions of visitors each year, the underlying hazards cannot be ignored. The island faces significant challenges that extend beyond its current seismic activity. Addressing these risks will require stricter enforcement of building regulations and proactive disaster preparedness measures to ensure that Santorini remains not only a stunning destination, but also a safe one. The Hellenic Arc subduction zone is where the African plate is slowly subducting beneath the Eurasian plate, generating frequent seismic activity, volcanic eruptions, and tsunamis. This region has a long history of devastating earthquakes, including the 365 AD Crete earthquake, M8.0+, which caused a massive tsunami that impacted North Africa, Italy, and beyond. More recently, the 2021 Crete earthquake, M6.3, was a stark reminder of the region's seismic potential. The sheer number of tremors in the past day suggests a period of heightened seismic activity, and scientists are closely monitoring the situation for signs of increased stress along the subduction interface. In the Middle East, a magnitude 4.8 earthquake struck 60 kilometers northeast of Jed Salman, Iran, on February 26, 2025, at 19:22 UTC+8, at a shallow depth of 10.0 kilometers. Iran is no stranger to powerful earthquakes, as it sits at the collision zone between the Arabian Plate and the Eurasian Plate. The Zagros Mountains, where this event occurred, have been shaped by intense tectonic forces, leading to frequent moderate to strong earthquakes. The country has experienced some of the deadliest quakes in history, including the 2003 BAM earthquake, M6.6, which claimed over 26,000 lives. While today's event was moderate, its shallow depth makes it more likely to have been felt by local populations, and further monitoring is needed to assess potential aftershocks. Lastly, in the remote Arctic wilderness, a magnitude 4.7 earthquake shook the Chukotka region of Russia at 10 kilometers depth. While seismic activity in this area is less frequent than in the Pacific Ring of Fire, it remains a region of interest due to its proximity to the Bering Sea fault system, which is influenced by complex interactions between the Eurasian and North American tectonic plates. If you found this update helpful, don't forget to like, share, and subscribe for the latest breaking seismic news. Hit that notification bell so you never miss an update. Thanks for watching, and I'll see you in the next one. Stay safe out there.